Good day. In this video, I will explain about the second law of thermodynamics. It's related to the first law, where is heat always flow from hot to cold object, and it never cold to hot. And the extension when energy is converted. And as we know, the energy can be created but cannot be destroyed. I will explain the theory from the diagram, which I will explain more detail about the first law. This is the hot coffee in the cup. We can see the temperature in the coffee decrease after a while because the heat been transferred from the hot to cold. It can be transferred to the wall. Is called the system. Heat can be converted and lost. As the formula, we use work in equal to work out plus heat. So, as a conclusion, work heat is work in is greater than work out. Now I will explain about the heat engine. Heat engine receives heat from high temperature. For example of the heat engine is solar energy, oil, furnace, and nuclear reactor. They can be convert part of this heat to work. For example of the product is a turbine. Turbine which can convert from the water flow to the electric, and they can operate on the cycle. For example, is a piston. You can see a piston is a cycle to the from the fuel to the I will explain more detail about the heat engine. Usually, heat engine involves a fluid to transfer the heat. Engine that involved in internal combustion, such as a gas turbine and a car engine. But the best fit to the heat engine is steam power plant. This is the schematic of the steam power plant. This is the pump, boiler, turbine, and condenser. It flows through a cycle. When the work in, which is the water, is pumped into the boiler to make it steam. Is a gas that will move the turbine and generate work out, which is electricity. And from the gas, the gas will flow again to the condenser to make it fluid again, and it can flow and make a cycle again and again. From this schematic, you can find the formula, which is W net out. This W net, you can find the W net if we use the formula W net out equal to W out minus W in. For a simple we will discuss the example in second law of thermodynamics, which is a heat engine. I have an example for the question. We will find the fuel consumption rate of the engine. A car engine with power output, this is the question. A car engine with power output of 65 horsepower has a thermal efficiency of 24%. We will find the fuel consumption rate of a car if have a heating value 44,000 kilojoule, and the energy release for the LBM of the fuel burn. This is a schematic diagram of the question. The combustion chamber will enter the car engine and release the to atmosphere, and we can find the W net out at here. Equal to 65 horsepower. First, we will take the point. This is 65 horsepower for the engine, and efficiency for the car. Our output is 65 horsepower, and the thermal efficiency is 24%. And we find the fuel consumption if the heating value is 44,000 kilojoule. Heating value to 44,000 kilojoule. We will use the formula of Q naught H equal to W net out over the horsepower. This is the thermal efficiency, and you can calculate, which is and over 1 horsepower. And we can find the answer is 202 kilowatt. From this answer, we can find the mass flow rate of the car, which is 10 flow rate to 202 kilowatt over the heating value 44,000 kilojoule, and after calculate we will find the answer is 0.0004559 kilogram per second. This is the fuel consumption per kilogram. Hi there. This is a subtopic in second law of thermodynamics, which is the thermal efficiency. Thermal efficiency is a measure of the performance of a heat engine. From the thermal efficiency, we can find this is the formula. Performance equal to desired output over required output. This is you want to find the performance of the car. And second is the thermal efficiency, which is equal to net work output over total heat input. This is the formula, which is W net out over Q in. From this formula, we can find the thermal efficiency. We can simplify into this formula, which is W net out is equal to W Q in minus Q out.